Okay, so I had trouble seeing your picture that you sent me, so I'm just going to work through problem 5 and 17 in this video with the numbers that are coming up for me, and I think that'll be helpful. And then you can see if you can figure out where you made your mistake. And I usually just do the whole problem because it doesn't make sense to just do one part. So for my problem 5, I have a mass of 0.18 kilograms, and then the equation of motion for the simple harmonic oscillator is 0.7 meters cosine 10t. So looking at that expression, I can see that the amplitude is 0.7 and omega is equal to 10 for this particular problem. So the first question is, what's the amplitude? And that one's relatively simple to find from the equation because it's just this coefficient, so it's 0.7 meters. And then B, the force constant for the spring is K. And so we use omega is equal to the square root of K over M. So we have to square that to get K without the square root. And so we see that K can be written as omega squared M, which will be 100, because that's 10 squared, times M, which is 0.18. And so that's going to be 18 newtons per meter. So we got that. C is the position of the mass after it's been oscillating for 1/2 a period. And so in order to answer that question, we're going to have to figure out what the period is. So if I go back to the idea that omega is the square root of K over M, that's also equal to 2 pi f, which is 2 pi over the period. I can solve for period as 2 pi square root of M over K plus 2 pi square root of 0.18 over 18. So I got to do the calculations because my numbers were different the first time through. Oops. And hopefully I don't make any mistakes along the way. So I got 0.628 for the period. And so now what I want to do is to find that answer. I need to put half of that into this expression, which is 0.3142, and find that. And so the problem here is we have to make sure that our calculator is in radians. So I'm changing the function so that it knows that when you put your angle in, it's in radians. So I'm going to take 10 times that, and then take the cosine of that angle and multiply it by 0.7, and I got x is equal to minus 0.7 meters. So I did that. And then D is 2/3 the period, so let's figure out what that time is. That's 0.419 seconds. So I'm going to do that again. And I got minus 0.35 meters. So I got those two. Now we're going to the one that you actually want to see. But I'm hoping that this is all helpful, so I'm just going to write this expression again so we remember it. Now this one is where you're trying to figure out what the time is. So we're saying x is equal to minus 0.3. Your number for x might be different, but it's still the same idea, so this shouldn't be unhelpful. So I'm basically trying to figure out what that angle is. So we have to do the inverse cosine. First I'm going to minus 0.3 over 0.7 equals the cosine of 10t. And so 10t is the angle whose cosine is minus 0.3 over 0.7. So we're at 0.3. So I got that 10t is 2.01, and then I'll divide it by 10, which would give me 0.201. Again, remember that your calculator has to be set to radians, because that's how they're given your answer. So I'm hoping that that's helpful for that number. All right, so number 17 I am going to stick to B, because the first one was just multiple choice, part A. So in my problem with my numbers, again, your numbers might be a little bit different, but the idea is going to be the same, is if you take a pendulum and you decrease the length by 6.95%, what's going to happen to the period? And so you want to express it in terms of the old period, and we'll look at how you would do that. Decreasing it by 6.95%, another way to look at that is that the new length is 93.05% of the old length, which I find using that number is more useful. The way that we could write that is if this represents the new, L sub n represents the new length, is 0.9305 times the old length, because keep in mind that this is equal to 93.05%. Now I'm going to write two expressions. One is for the old length, in terms of the period, would be the square root of L old over G, and then T of the new is equal to 2 pi the square root of L new over G. And I can write the new is 0.9305 times the old length. I'm going to do that. And so what I want to do is I want to compare the two. So I'm going to write a ratio, T new over T old, be 2 pi the square root of 0.9305 L naught over G, and then the old is 2 pi the square root L naught over G. So this becomes 2 pi square root 0.9305 L naught for G, and then I'm going to multiply by the reciprocal, G over L naught. So this allows me to cancel some things out, get rid of the 2 pi, the G cancels out, and the L naught cancels out, and the ratio ends up to just be 0.9305 over 1, and so if I 0.9305 square root of that, which is equal to 0.9646. And so I don't want to keep this on this paper. This means that this is equal to T new over T old, and so I can write that as T new is 0.965 times T old. And that's how you find that. So hopefully that helps.